All right, so we wrote one line of code yesterday. So I have library ggplot first. Now I have, now that you can see this red button here. So R was working, it was librarying it, took 2-3 seconds. Uh, then next thing is that you can, uh, okay, let me tell you about some data sets which are already there in R. Right? So for example, if I take data sets, if you just type this data sets and colon and then again a colon, you will see a lot of data sets which are there. And we can use any one of them without having to import anything. So I will be using these already existing data sets. The only difference will be that when you import a data set, you will save it as an object, and then you will use that name in the command. In this case, I will not be importing any data set, but I'll be using the already existing data set, and that also has a name, and I'll be using that name of that data frame instead of the imported one. Otherwise, everything else remains the same. So let me show you a few data sets. So we can use any one of them. Let me show you iris, or instead of writing line number 2, you can directly write uh, view iris. So you will see the data set. Let me admit somebody who's there. All right. So this iris, and one more thing, if you just write a question mark ahead of iris and run that line, you will see uh, documentation on that data set. So this iris is a data frame with 150 rows and 5 variables and columns, which are these, right? And it is about measurements in centimeters of variables, sepal length, width, petal length, and petal width for 50 flowers from each of the 3 species of iris. The species are setosa, versicolor, and virginica, right? So it's about flowers, and there are 150 rows. So each row is a flower. If you take row 1, let us call it flower number 1. This flower has a sepal length of 5.1 centimeters, sepal width of 3.5, petal length of 1.4, petal width of 0.2, and this flower belongs to the species Setosa. If you move down, there will be a flower at line number 75, flower number 75, which has these specific sepal length, sepal width, petal width, and it belongs to another species of flowers called versicolor. So there are in total 3 species in the entire data set, 3 different species of flowers for which the measurements are taken, right? So this data set I'm going to use now. Just briefing you about little bit about the kind of variables these are. So the first 4 are numbers. So each column is a numeric vector, and then the fifth one, species, is a categorical variable. This is known as factor in the language of R. We call it a factor, right? So let me write it here. A categorical variable is known as factor. The categories are called levels. In Iris data frame, the factor species is has 3 levels, and those are, let me not write the names. So those are actually versicolor, virginica, and setosa, right? That's our data set. Now, when we are plotting a particular data set or plotting variables on a graph, we have to understand that what we are plotting and what is the best graphical representation of that particular data. So we must have some understanding of the usage of a bar chart or a column chart or a scatter plot or or box plot. What kind of plot we want to is best for that particular type of data, or let me call it those particular types of variables that I want to put on the canvas. So that comes from statistics, and of course, I will not be teaching you that part, that theory part. So I will be showing you practically only how to do it in R. Right? So, but in the middle of it, wherever required, I will try to explain the data and the data set, the variables, and some understanding I'll try to give you about the particular type of plot that would be best for that particular data set. So let me start with ggplot. So every command of this package starts from this ggplot, open parenthesis, close parenthesis. The first argument is the data frame. So if you have imported a data frame and if you have saved it as ABCD or whatever the name you have given it, that that would be the name of the data frame that you are having with you in your R, and you'll be putting that name here. For example, yesterday I could have I saved teacher salary as A, so I put A here and then a comma. So in this case, I'll put Iris because this is the name by which this exists. This data frame is there. I can change this name right now if you want. I can make it A, right? So if I do it, I will be just running these lines, and that's it. This will save it as A. So Iris will be contained in A, and then I can use A here, right? But let me not do this. Uh, I write a note here if I wanted to change the name of the data frame Iris to A. But I didn't do that, so I'll be using the already existing name, which is Iris, right? So I already told R that please use this data. So R knows it that Iris is the data set that it has to use to plot the graph. Then comes a comma, and after the comma, the second argument will start. The second argument is generally AES, where AES means aesthetics. Aesthetics means you have to tell R that what variable you are mapping to which attribute of the graph. So generally, we map something to X, some variable to X, and just to see the correct spelling of the variable names, I'm writing one additional command here, names Iris. So that would give me the names of the variables in my console, so I can read it from there and type it here. I can copy paste also, right? You can just copy it there, copy it from there, and then type it. I mean, paste it. Okay, so let me take sepal dot length and sepal dot width. So what I did here is I have mapped x-axis to sepal length and y-axis to sepal width. And if I run this line, you'll see a red button here that shows that R is working. Doesn't take that much of a time. I don't know why it is taking so much time.
So I have one question in this.
Yeah.
Like when we put in aesthetic, it already understands as x and y axis. So do we have to say that x equals or y equals, or will it
No,
take it
we don't.
automatically?
We don't have to say it. You
Ah,
can,
okay.
it's not required. You can just remove that part. X equals to this,
Okay.
Y equals to this.
Yeah.
That would do fine, right? No problem.
Okay. Okay.
But in case when you are writing Y first and X second, then you have to mention it that the first one is a Y and the second one is a X.
Okay. Okay. All right. Thank you.
All right, so you see this blank canvas here, nothing is plotted on it, although the x-axis is mapped, sorry, sepal length is mapped to x-axis and sepal width is mapped to y-axis. So you can see the scale is also right. The numbers match the numbers in the data. The numbers on the graph, they match the numbers on the data. So now, once you have done this, you write a plus. Now, this plus means I want to put one layer over this already existing blank canvas. So ggplot works in layers. Let me write this note also. You can superimpose layers over layers on the same canvas, right? So the first layer is the blank canvas, and now I have written this plus sign for the very first time. After the plus sign, I am pressing enter to switch the line, and the cursor will be taken to the right position automatically. You can see that the cursor did not go to the very beginning of line number 13. It just went somewhere in the middle, right? So R knows that the command is incomplete and there's a plus, and after that plus something has to come. So R knows exactly where to take the cursor. Even if you continue writing in one line, it will work completely fine and there is nothing wrong in it. But as I said before also that there's a good way of writing code, a neat way. So you can think of this method of switching the lines at the right time being uh, a method of a good student who keeps the notebook clean and tidy, right? Of course, there is one more importance of it is that whenever you come across a very big line of code, uh, it is at times uh, easy to read it vertically rather than horizontally. So if things are stacked one over another, like a column, it is easier for the eye to read, especially something like a command or a formula. This is also a very important, reason why we switch lines.
Sir, can you please repeat this point, the last point?
Uh, the last point I said that when you're writing a very long line of code, uh, then of course you will pass through this end point of this panel, and then whenever you want to read it, you have to go horizontally from left to right, and then your eye will take some more time, a little bit more time. Then if you switch the line and the line can read horizontally, eye can read horizontally as well as vertically. So it can just look down and understand in one glance that what what is written in the code, right?
Okay, thank you, sir.
Okay. Right. So the first layer is already there. The second layer is coming up. And the second layer after a plus, it's going to be a geometry. So that always starts with GEOM, geom, and this geom stands for geometry. So I'm trying to provide some sort of geometry to the graph. So this geom will determine that what kind of plot I'm going to do. So if I write point, it is going to be a scatter plot, right? If I write box plot, it's going to be a box plot. If I write line, it's going to be a line plot. If I write violin, it's going to be a violin plot, right? If I write bar, it's going to be a bar plot. If I write call, it's going to be a column plot. So there are lots and lots of things. Of course, this choice of the geom uh, depends a great deal on the choice of the variables. So I've chosen these two variables, and I know that both of these are numbers. So they are measured on a ratio interval scale or a continuous scale rather than a qualitative or nominal ordinal scale. So there are some geoms which will be better and good in this situation rather than others. So we'll see many of them. So let us start with one of them, that is geom point. And let me run this code. As soon as I run it, I'll be able to see this plot. Let me explain the plot a little bit. Each dot or each point on this canvas is a flower, and the x coordinate corresponding to that point and the y coordinate corresponding to that point uh, are the measurements on sepal length and sepal width. So where does a particular flower, where it is situated on this canvas, is telling us that how big or how small sepal length and sepal width is for that flower. So a flower which has a large sepal length, so that means it's a big flower, and also a large sepal width, that means it is a wide flower, so it's lengthy and it's wide, so it's a big flower, will be situated in the top right corner of this plot. That dot or that point corresponding to such a big flower will be somewhere on the top right corner, not the corner, towards, let me call it quadrant, in the top right quadrant of this plot. And another flower that has a small sepal length like this one, so its sepal length should be something like 2.5, and its sepal width is something like 2.4. This is a small flower, and this will be situated at the bottom left corner of the of this plot. Similarly, a flower which is at the top left corner will have a bigger, a wider sepal width, and it will not be lengthy, it will be small in length, right? And so on and so forth. So this tells us that the plot tells us the correlation between the variables on the x-axis and the y-axis.
So just
So
one clarification I'm asking. When we are doing this ggplot thing, we're collecting the data from the iris data,
yeah,
right? And aesthetic means we're mapping sepal length on x-axis and sepal width on the y-axis. And when we
right,
are giving this additional command of geo point, this geometry point, right?
right.
So what are this data all about? You said just mentioned the correlation you were saying that of the of any flower, particular flower. between its sepal width and sepal length that it shares. Is it like that?
Yes,
Individual. Acha.
yes. So if the dots uh, are situated, if you draw a line
Hmm.
diagonally, two lines can be drawn because
Hmm.
this plotting area is a rectangle.
Hmm.
Two diagonals can be drawn.
Hmm.
So the diagonal that goes up from left to right,
Hmm.
if the points are situated around that line, that diagonal,
Hmm.
most of the points are situated around that line. That means there is a large positive correlation between sepal length and sepal width.
Acha.
The closer the points to the line, the larger the value of correlation. The farther the points from that line, the weaker the correlation.
So are you talking about the line of best fit or what? Like
No,
when we regress?
I never said that. I said that if you just draw two diagonals of this
Uh,
rectangle,
acha.
right? Just
So
the
any one and arbitrary diagonal lines you're talking about,
No,
not
not
not.
arbitrary. A rectangle has one particular diagonal that goes from
Ah,
left to right, and another diagonal from that goes down from left to right. There can only be two diagonals, right?
okay.
Can you hover your mouse? Yeah, it will be easy for us.
Yeah. So if you start from this corner and you draw a line that connects this corner and this corner, that will be the one diagonal that goes up from left to right. And then if you start from here, the top left corner, and draw a straight line joining it to the bottom right corner, that will be another diagonal. So there can be two possible diagonals on this canvas, right? So if you take the first one, which goes up from left to right, and if you see that most of the points are close, are around that line, that means there is a positive relationship between sepal length and sepal width, or positive correlation between sepal length and sepal width. And it depends on whether the points are scattered, or if they are very, very close to the line, that would determine the strength of correlation. So is it weak or is it strong? So the closer they are to the line, the stronger the correlation, right? So similarly, the other way around is that if the points are situated on the other diagonal that goes down from left to right, in that case, we would say that there is a negative correlation between sepal length and sepal width. And again, how close are those points to the line will determine the strength of the negative correlation. So is it a strong negative correlation or is it a weak negative correlation? So correlation can be weak negative, strong negative. It can be weak positive, strong positive. It can be moderate negative, moderate positive. So these are six ways to explain correlation in words. So let me not go to correlation
So
because that would take us to
just
statistics.
sir, just to understand, just one final query. We are
Yeah,
just doing this diagonal thing from left to right or left right to left, just to understand the direction of correlation and the strength of the correlation. Like we
exactly,
talked about. Okay, okay, fine.
exactly.
Okay.
So when I'm teaching data visualization, I have a lot of chances of going into statistics. So which I don't want in this workshop, because we are here to learn how to do statistics. I mean visualization in R. So let's stick to that. I'll try to do that as much as possible. So anyway, so we got this point. Now let me just come to the point and try and do things on this gray black graph to make it more appealing, or better in terms of presentation. So suppose I don't want black.
Sir, I'm not able to get the graph.
Which part? You have to tell me which
So
part.
12th part, when I'm running 12th line,
Hmm.
I'm not able to get the graph.
Okay. Did you run line number one?
Yes, sir, library ggplot. In 12 number 9, we have to write ggplot or ggplot 1. Like without any number in
So
12.
what do you see here?
Here no 2 is there.
So you don't have to write it.
Okay, so I'm not able to get it. Like without 2, I'm not able to.
No, don't write a 2 here. You have to write the command as it is.
Yes, I've written exactly the same command, but I'm not able to get it. But in library we have library the ggplot 2, but in 12th line we are writing without 2. So is there any difference or?
See, there is this name of the package, ggplot2,
Yes, sir.
right? And the command starts with ggplot, not ggplot2. That is the
It is
name.
saying it is saying duplicated aesthetics after name standardization.
Uh,
Okay, this is sepal dot. Sorry, I have written the comma. Sorry. Okay, sir. I'll.
yes, yes. If you are missing a comma or something, you will not get it right. So please take care of the commas and all of those things, capital, small.
Got it, sir. Got it.
All right. So let me change the color of the dots. So I'll write color equals red in the geom point, and it will make them red, right? You can make them of any color. Another thing, let me change the size of the point. So let me make it 3. That would make them bigger. So you can adjust the size. You can make them big or small. Uh, Let me change the shape to 21. So there are shapes, and you can give numbers and see which shapes are which numbers. Experiment with shape 1, shape 2, shape 3, so on and so forth. Let me write a fill. Fill equals yellow, right? Let me change one more thing. Stroke equals 2. Alpha equals 0.5. So when you're doing it one by one, just see what it is doing. Or you can ask me if you don't understand any of these.
So what does alpha mean?
Alpha means transparency. So if you want to make your points transparent, and if you want to make them half transparent, you have to use it to be zero point 0.5. If you use it to be zero point 0.2, it will make them 80% transparent. If you use zero point 0.8, it will make them 20% transparent. So the smaller the alpha, the more the transparency.
And what does the stroke means?
Stroke means the width of the outer ring. So the bigger the stroke, let me change this to 1. So now this width will become smaller, the outside ring width. If I make it 3, it will be very, very wide. So the yellow color will be very small, and most of it will look like red. The ring will have a higher width. Uh, you can see that they are overlapping. So alpha is a good idea when you have overlapping graph. So there can be 2 3 points sitting one over another, and you can't see them because of they are completely covering each other, right? So in that case, if you reduce the alpha, you would be able to see some dark areas. So those dark areas are those where there is more overlapping, and there will be some areas which will not be dark but light. Those will be the areas where there is no overlapping. Any other question on this? Great. So
So I have a question.
yeah,
So just wanted to ask, this kind of ggplot will be used in what kind of analysis we can show it like?
this is a scatter plot actually.
Uh-huh.
So again, if you have two continuous variables,
Okay.
two continuous variables. Continuous means quantitative, right?
Yes, sir.
You can use it.
And so we have a different set of variables. Like for example, in my research, I have to show different kind of people. For example, like my topic is related to stock market, so I
Okay.
need to show related to the homemakers, IT professionals, and in that way. So in that way, so we can show different colors. Like we can plot it that way.
You want to show different colors, right? For
Yes, sir.
different.
So along with this red and yellow, also I need to show more colors.
Okay.
Specifying
So
this is red and yellow is for homemakers.
okay.
Green and blue is for
Okay.
professionals.
Wonderful. So that can be done. Let me show you that. So let me ask you to visualize the data like it is your data, and this species variable is the uh, you know uh, category of people. So Setosa is homemakers, and uh, versicolor is salaried, working people,
So,
and say then there is a third one. Virginica is some other category of people. Or let me call them doctors and engineers and teachers. So Setosa is teachers, versicolor is doctors, and Virginica are engineers. And you want to show them with different colors, right?
Yes,
Anyone
sir.
anyone asking a question in the middle?
Uh, yes, sir.
Yeah, please ask.
Sir, you give the command for yellow red, it keep on changing, the size has increased, but in my case, nothing happened. Unexpected symbol, fill yellow color is showing error.
So
I can help you in this. You have missed the comma. I had the same mistake, so I have missed the comma. Just
Oh
check
my
it out
god.
that way.
so it has to be in quotes, the name of the color in
Uh-huh.
quotes, and
Mm-hmm.
also there is a comma after the quotes. So after every line there is a comma.
Thank you, sir. Thank you, sir. It worked. Thank you.
All right. Okay, let's come back to what we were doing. She presented a situation in which there are some categories of people: doctors, engineers, lawyers, and uh, these each of these dot represent a particular row of the data. So can we make some rows green, some red, some blue, so we can see which of these are doctors, which of these are engineers, or Setosa, versicolor, and virginica flowers. So in that case, I'll start with ggplot, use the data iris, map the same sepal length on the x-axis and the same sepal width on the y-axis, and then add a layer of geom underscore point. So up to this point, nothing is changed. Everything is the same. Whatever was there in line number 12, it is there here also, right? Now what I'm going to change is, I will write uh, color, instead of color, I'll write fill. Let me write color to make it simple. Color equals uh, species.
It shows colors actually, like
No,
with
no.
an S, I think, isn't it?
I think I'm making some mistake in the spelling. Sepal.length, sepal.wing, geom underscore point, color. Okay, sorry. I just missed one thing here, and that is AES. This has to be written in, AES. I'll explain why. So here is your graph. All the red dots are the flowers of species Setosa. So these are your homemakers, and the green ones are your the second category, and the blue ones is the third category. Now you can locate your what kinds of let us say sepal length is the salary and sepal width is the experience. So what kind of experience and salary these homemakers have and these other categories have? You can compare them using the colors on the canvas. Did you get it?
Yes, sir. So, but I'm not getting on my. So I'm getting an error. Unknown color name species.
Capital S,
Yes, sir. Done.
okay, COLOR, not colors but color,
COLOR, right, sir.
and there has to be AES at the at
So that is
the
also
head of
given.
it.
So also I wanted to ask one more thing. So as you have given a command in 12th and 13, so we can copy paste it directly. We need to type every time.
You can copy paste it. No need
Okay.
to type.
Acha. How
Yeah,
so? So
if
I
you
think
are
I'm not making any mistake.
no, you can just copy paste everything and then change the command according to your need, right? Just select it and then Control C and then you know copy and then paste and you can do all those things. No problem. Okay, let me explain what I did in this last line. In the last line, color, which is an attribute of the graph, is mapped, and I want to stress on this word, mapped to the variable, to species, which is a variable in the data set. So I explained to you in the beginning that you have to use AES to map something to something. And exactly what I mean by something to something is you want to map an attribute of the graph to a variable in the data set. So I mapped color, which is an attribute of the graph, because this attribute will change when a variable in my data set, which is species, changes. So when species changes from versicolor to virginica, color changes from green to blue. And keep it in mind, color is an attribute of the graph and it is mapped to a variable, and a variable is something that changes. So that it, when I map these two things, the attribute of the graph will change when the value of the variable changes. This is called mapping, and this is always done inside AES. aesthetics. I mean, this is not for this graph. It will always be. This is a rule, a method. It's a part of the language that we are learning. What should we write in the AES?
So may I?
Yeah, please.
So just two questions. So
Yeah.
here you have not mentioned green and blue color. So from where this they have plot?
Okay. Okay. What is your second question?
They have. So you have not mentioned blue and green
Yes,
color.
I got it. Second question.
So the second question is like. So I'm getting an error. I could not get the plots.
You have to type exactly how
So
I have
I
typed.
did exactly the same. So
Take a photo of the of that command and
I
send
will
in.
just share it. So.
Yeah. All right. So let me. In the meantime, I'll answer the question. Okay. If anyone else has a question, please ask.
I have this thing about the color which I said because in mine I've used COLOUR and you've used COLOR. Does
Yeah.
that make any difference?
Both can work. No problem.
Okay.
Yeah.
Because COLOUR, when I typed, I could see that and I just selected it.
It's okay. COLOUR and COLOR. But there is no third way.
No.
These are the only two ways in which you can write color.
All right. Yeah.
You cannot write colors. That will not work.
Yeah, that I got it. Okay. Yeah.
Yeah. Anyone else? Any question whatsoever? Whatever comes to your mind.
I want to ask something.
Yeah.
May I? Yeah. So, so this is coming out very nicely. One is I wanted to ask if is it possible to plot this from the origin like 00 rather than choose rather than like we can we alter the axis and what is the way to do it,
Okay.
and if for instance one also wants to put a unit along with the length and the width,
Okay.
so does one have to do it in the data or does one do it here?
Okay.
Yeah.
Okay. Okay. Any other question? Let me take the questions. I'll answer all of them one by one.
So just one clarification. When you're putting these lines 13 and 14, you're putting color and fill equals to yellow, right?
Right.
It's quite similar to the question, but again the same question that somebody asked before. So this line, when you're running this 12 and 14, this is separate command, and when I'm running 20, this is separate command, right?
Yeah, there are two separate commands.
Okay. And exactly the same question, like we are not assigning any color, as in the case of initial, like we are colored equals to red and fill equals to yellow.
Yes.
But in this case, we are not assigning any color. How come it takes red, green, and blue on its own, and not
Okay.
any other color?
Okay. So let me answer the color one first. So there are some default colors which are there, and R would choose them intelligently according to the need. So there are palettes actually. So there are palettes which contain colors which are distinct. So they will be used when there are when some sort of categorical variable is mapped. So in this case, color is mapped to species, and species has three categories. So R needs three colors, and species is a categorical variable. So distinct colors were required, and there was a palette which matched this sort of situation. So it selected it automatically, right? Now
Right.
there might be
So
there
my
might
error is being solved, sir. Sir, I was having the problem with alpha. So I had a 0.08. It should be 0.05. Now I can see the plots.
Okay, so did you use alpha in line number 20 also?
So the above one. No,
The
sir,
upper
not in
one.
20. Not in 2018. It was 0.8.
Okay, okay,
And
like okay, okay. So
yes, sir.
coming back to the color, so there are these palettes which are there, and R would choose it automatically. It's not that you don't assign your colors; you can do that. I'll tell you. I'll tell you how to do that. And but R chooses intelligently. There is another situation in which you are mapping color to a variable which is not categorical. Suppose it is quantitative, and there are numbers. So there's a number 3, and there's a number 7, and there's a number 12 in the data. How would you, and there are all sorts of numbers. So if there are 100 values, there are 100 numbers. So R will is not going to give 100 different colors, right? So in that case, R will choose shades of the same color. So the darker the color, the higher the value. This sort of assignment is done by R automatically, right? So this is the answer to the color question. Uh, Let me quickly, but if I write it here, you will, you know, don't don't bother to write anything. Just for showing, I'm writing because our color brewer is something which is there, and if you write display brewer all and run this line, you will see the palettes which are there in R, and they all have names. So you can choose a palette by its name. So if you want paired, you can choose this one. If you want dark two, you want set one, set two, set three. You want purple, you want this, that. So there are these are the default palettes which are available. If you want, you can choose one of them. So though that combination will be there. Apart from this, this choice of palettes, of course, you can choose your colors. So you can mention which color you want, and you will get that color. So that I will tell you uh, after some time. Uh, Let me answer the other two questions also. So the other question was access. So why is it not starting from zero? So it is not starting from zero because there is no data uh, which is there around zero, and it is ending at 8 on the x-axis because there is no data on 10. So there is no point bringing that 10 into the picture and that those small values into the picture, because that would shrink your plotting area and your graph will not look good. But if you want to uh, force it to start from zero, let me x limit 0 to 10. You would see that now it is starting from zero because you have assigned your limits to the x-axis, and similarly you can assign the y limits also, 0 to 6, not 4.5. So you can see that by including those smaller and the bigger values, you have shrunken your area of plotting area. But and nonetheless, it is important to learn these things so that you have the control rather than letting R to do. However, of course, it does it in a optimum way. Okay, what was your next question? One more
Uh,
question.
I also asked if the units can be
Oh,
indicated in the sepal width or the
got it. Got it.
sepal length. Yeah.
All right. So for that, let me add one more layer to it. And you can write labs, uh, modify axis legend, plot labels. Okay. So labs, so if you use labs, you can write a title, my plot. You can write a subtitle. You can try type a X label. Okay, this label is not changing. Let me try theme. Okay, got it. It's here in theme actually. So access text dot x access title dot x access title. Okay. Let me try this. Access dot title dot x equals xyz. Access dot title equals xyz. Okay, it just slipped my mind where I have to see it. I'll see to it. I'll let you know. Of course, in the access title, I can write centimeters, meters, whatever I want. So I'll let you know how to do that. It's slipping my mind. Sometimes things get messed up, so it doesn't come.
Yeah, yeah. Thanks. Yeah.
All right. Okay. So any other thing?
Sir, are we going to cover only visualization today or something else also like regression
No,
and all
no.
that?
Visualization today is for
Okay.
visualization. Tomorrow also we'll do some visualization.
Sir, I requested you to use some secondary data source, like if it's possible to do
So we
that,
can
no?
we can
Instead of
do that.
using the data set, sir.
Yeah, we can do that. That teacher salary data or some other data from there. Then we have to import it, right?
Oh.
So yesterday I made you work on that, right?
Sir, actually, this teacher salary, all this, so you have created data on your own, actually, I guess so. No?
So that is all secondary data basically.
Means is it some other source like NFHS data or PLS or PLFS data or NSSO data? Is it similar to
Uh, I mean, how does it? It doesn't make any difference if you are using NFHS data or if you are using any other data set from any secondary source. So because
what?
what you are going to do is to just replace this iris with that
Okay.
data set, right?
Okay.
And the variable sepal length will be replaced by income, and then sepal width will be changed with
No,
your
actually, sir, in any case, if we were using any of these data sources, I understand, sir. एक ही बात है. But the thing is that why I was harping more on these data sources, that is any way of like the way you very smoothly took a lot of time in making other people understand how to install R and all that thing.
right, right,
So
right.
I just wanted a basic understanding how do we extract data from this. I know how to extract data from PLFS and NSSO and NFHS, but I was thinking of how to do a little bit of revision, or if you could, if you did that, take
Yeah.
the
So
help of the data
so
source.
actually tomorrow is the day for data extraction. So I've left it for tomorrow.
अच्छा अच्छा ठीक है sir. Okay then.
So that is day 5 thing. So tomorrow I'll be showing you how to extract the data. Today I'm showing you visualization because
Okay
it is
okay
in the plan like that.
okay sir. Okay, no issues. Thank
Uh, if you ask me, maybe tomorrow when we will extract that NFHS data or PLFS data,
you.
you can remind me to plot that. So at
Mm-hmm.
that time it will be here. All of
Okay
us will be having that. We would have
okay
spent some 1 hour to do that. After that,
okay
we can do some plotting on that.
Okay, sir. Okay.
right? All right, and so let's move forward. Uh,
Acha,
let Yeah.
this R color brewer, uh,
Hmm.
really didn't understand it. What is, how does one use it? We have to, is it by moving the mouse on it?
No, actually, to use it, you have to write uh, color. Uh, I'll show you how to use individual colors. But this color brewer, which I wrote here, it was just to show you that these are the colors available, and it chooses some colors from the already existing set of colors,
Right, right.
right?
Okay.
So you will not be able to use them because R will choose it automatically, right? If you want to use your colors, I'll show you that how to use your own colors, right?
Okay. Okay. Yeah.
That brewer will be automatically chosen. Any particular palette will be chosen.
Okay. All right.
All right. So let us do geom box plot. So there is a data set called MPG. Or should I use the same data set? Should I change it? This is the MPG data set. The name of the data set is MPG. So it's about cars, and there is a particular each row is a car, and then each car has a manufacturer, model, displacement, year, CYL, number of cylinders, DRV, city mileage, highway mileage, class, what type of car it is, right? So it's about 234 cars and 11 variables. And these variables are which manufacturer, what model, what is the displacement, what is the year of manufacture, how many cylinders does the car have, what type of transmission, is it automatic or manual, is it a four-wheel drive F, is it four, is it a front wheel drive F, is it a rear wheel drive R, what is the city mileage, what is highway mileage, all those things are there. What type of car it is it a compact, is it a SUV or a two-seater. So this data set I am using, and I want to show you a box plot. So the first argument is MPG, which is the name of the data frame. Last time I used iris here. Now I'm using miles per gallon, that is MPG. And then aesthetics. Before that, let me write the names just to see the spelling. So that I can read it from my console. So what is on the x-axis? Let me take highway mileage on the x-axis. There is no need of y-axis. And then geom underscore box plot, and just run it. So this is the box plot. Uh, how to read a box plot? So there are you'll see a box, and only one variable is there, that is on the x-axis, and that variable is highway mileage, and you can see the numbers 20, 30, 40, and we have a box where there's a line in the middle, the bold line. This is the median actually. So the median highway mileage is this much, somewhere around 24, right? So let me check the median. Median MPG HWY. So it is 24 actually. So this line is at 24. So you can see the median, and then the end, the point at which the box ends, this point where I'm hovering, this is the first quartile. Then the farther point where the box ends, this is the third quartile, right? And then there are these lines to the left and to the right. This is the interquartile range. And then there are points, 2 points are shown which are outside this range. These 2 points are the outliers, right? So uh, should I tell you a little bit about first quartile, third quartile, interquartile range, and outliers? Do you want me to explain them a little bit? If you are aware, we can move forward.
No, sir, explain a little bit. It will help, I guess.
What about others?
So I have a question. Hello. So am I audible?
Yes, yes, you are. Please carry
Yes,
on.
sir. So I just wanted to ask, as we got the plots, so how are we going to show in our similar how to export it, or how we are going to place it on a Word file?
All right. So you would see this export tab here. Save as image, save as PDF, copy to clipboard. If you select copy to clipboard, you can go to the Word and paste it there, or you can save it as PDF, and then you can drag that PDF onto your Word file, or you can save as image and drag that image to the Word file. Three options, right?
Oh, fine. And sir, do we need to save our codes like whatever we put and we got this final result? So we need to save all this codes also, like how we have derived from this.
If you want to replicate it in the future, you want to keep it with you. It's a good idea, because sometimes when you come back after a long time, you tend to forget how you did this or that. You just have to change your code a little bit to get the other kinds of graphs. So it's a good idea to save the code, but it is not required for, because once you have imported, I mean saved the graph, it's done.
Got it, sir. Thank you.
All right. So let me explain you a little bit about Q1. Q1 is the first quartile. So first quartile is 18, around 18, and then the third quartile is around 28. So first quartile means which value in the data has 25% value which are lower to it, and 75% of the data is above that value. That is the first quartile. So first quartile divides all the values into 25%, 75% ratio. 25% below it, and 75% of the values are above it. Similarly, third quartile again is such that 75% of the values are below it and 25% of the values are above it in the sample, in the data that you are using to plot, right? So this is first quartile and third quartile. Median is that value in the data which divides the data into two equal halves, right? And there's a formula which uses the third quartile and the first quartile and the median to give you the a lower bound and upper bound that would be considered as interquartile range. Uh, I mean, not interquartile range is simply Q3 minus Q1 actually. So in this case, 28 minus 18, the interquartile range is 10, right? But then there is a formula which uses this interquartile range to decide that which of the, is there any outlier in the data. So outlier is that data point which is far from rest of the points. So if one of the values, if some of the values are very, very big as compared to most of the values, and if some of the values are very small as compared to the other values, those will be called as outliers. So when we do data analysis, we have to be skeptical about these data points because there might be several reasons why we got such values in the data. It might be, an observation which is coming from some other population. That's why it's so big or so small. It doesn't match the values that we already have. There might be some mistake you have made while you entered the data, right? There might be some other reasons. So that is statistics, and therefore we have to be skeptical. We have to see, understand why we got such high, such low values, and all those things. So when you plot your data, you want to give, sometimes you want to show them that you have some data points which are outliers and how many of them are there, right? So this box plot comes in handy when you want to understand the distribution of your data, of a particular variable in the data, right? Now let's make us let's improve this
Just
visually.
one, can I ask one query out there?
Yeah.
So when you talk about this quartile, I'm just asking a little bit of ecotrics. So is it something related with quantile regression that we do, or is it
Uh,
different from that?
yes, I mean quantile regression is uses quantiles, and
Hmm.
quantiles is a generic word
Hmm.
for all the distributive measures like percentiles, like quartiles. You might distribute your data into 10 parts. You might distribute your data into 100 parts. So all of those are called quantiles. So quantile regression is not done on the the raw data that you have, but it is done using quantiles. Now those quantiles can be percentiles, right? So that quantile is a generic term. So quartiles will distribute the data into 4 equal parts, right? So you can,
Right, like
of course,
percentile, decile, and
yeah.
quantile,
So
that
of course you
depending on
don't
what.
want to, you
Hmm.
can't run a regression on quartiles, but yes,
Hmm.
quantiles is a generic term, and when you do regression using quantiles, uh, that is called quantile regression. But here we are talking about quartiles, so that means you are trying to distribute the data into 4 equal parts and see where are those values that divide, that do such a division.
That means these are two distinct concepts, right? They are not synonymous.
Yeah, it is. I mean, I said that quantile is a generic word. It includes quartiles also. It
Mm-hmm.
includes deciles, percentiles also.
All right, so thank you.
One question: can we
Yeah,
flip the x and y axis
we
here
can, we
so
can.
the distribution appears around the y axis?
Okay, let me try that. Flip dot co flip underscore pod. Or let me start with a pod underscore. Okay, I got it this time. Pod flip. Yeah, I did it. So if you use this cord underscore flip, it will flip it x to y, y to x. Right. So
Thanks.
let me,
Thanks.
yeah. So let me
Yeah.
improve this graph by, let me keep it this way only. Uh, some color. So what if I write color equals red? So it's going to make it red, of course. What about if I write fill equals uh, light blue? It will fill the color. Of
But
course,
your screen is not visible. Can you just
What is not visible?
The screen.
Is it? Is it not visible to others also?
No, no, it's visible. I think something's problem in this.
Okay. Should I re? Okay, I'm stopping to present and then I'll start presenting again. Can you see it now?
Yes, sir.
Okay. Okay. Now next, what about alpha? It's making it lighter. It's already light blue, so not a good idea. Okay. Now I'm adding one more layer. Uh, Let me try this. NOTCH notch equals true. Let me include one more variable here, class. So it will show me as many, okay, because of this plus I'm getting these errors. Now it must run now. Now it is running. I put an extra plus here and I just forgot after that, and then I was thinking what is happening to my plot. So now you can see a lot of box plots here. I have zoomed the screen. Can you see the zoomed screen? Uh, can you see the zoomed screen?
No, sir.
Right. So you can click on zoom here and see yourself if you are working. There are 7 box plots. It is because I have added another variable here. So I have mapped something to the y-axis because there is a coordinate flip here. Therefore, that y-axis, something that was mapped to the y-axis, is shown on the x-axis, right? So class is shown on the x-axis because of this command, coord flip, right? So class is mapped to y-axis, which is showing on x-axis, and the class is a categorical variable. If you see here, this class is a categorical variable. I have mapped HWY highway mileage to the x-axis, and I have mapped class to y-axis. Now, how come R is going to tackle this? So it will see that class is a categorical variable. That means it understands I'm asking for a box plot for each class. So it plotted the data of all two-seater cars here, the very first box. The second box represents the data for or the highway mileage of compact cars, right? So what insight do you get from this graph into the data? Do, did you understand something extra from this?
Which car can run better on highway? Like it shows.
Exactly. So which car has a higher highway mileage? So the median
Sub.
highway mileage is higher for compact and mid-size cars, and it is low for pickup cars. The pickup cars have a lower median highway mileage, right? Another, any other insight? Okay, let me tell one thing. So the data or the highway mileages of all two-seater cars, mid-size cars, they don't have outliers. So the highway mileage of all two-seater cars are close to each other. There is no very high mileage car. There is no very low highway mileage car. So the data is distributed sort of uniformly across the range. While the compact cars are such that some of them have very high highway mileage. So such high highway mileage is there. Some of the cars are showing that it seems that they don't belong to this category, compact. It seems that they belong to some other category. Right? Similarly, similar is the case with the SUVs, the last one. So there are a lot of cars which have a very unusually high highway mileage and unusually low highway mileage. So there are some outliers in the highway mileage data of SUV cars. So some more insight into the data. If we see this uh, box plot as compared to one box plot for the entire highway mileage data, it's good to see category wise highway mileage of the cars.
Is this actual data, by the way?
It is.
It
It
is.
is actual data. Yeah, it is actual.
Okay. So SUVs, it speaks a lot about how badly SUVs are doing.
Yeah, I mean they have a low highway mileage, median highway mileage, and at the same time, some of them have higher than others highway mileage.
So is this data related with mileage? And that's
Yeah.
how we divide in the class.
Yes.
The
Yes.
MPG is about mileage thing.
Yeah. HWY is actually highway mileage
Highway.
of
Okay,
the
okay.
cars. Yeah.
So MPG, what does it mean? But what is the full form of the MPG like?
Miles
The
per
data.
gallon. Miles per
Okay,
gallon.
okay. And sir, regarding this box plots or different classes of the cars that you're talking about, so box plot, you were explaining this quartile thing, no? So the middle, when you're talking about this box plots that is being created, these dots are outliers you mentioned, right?
Yes. Yes.
And what about this thing like the horizontal line, the median? I think it's representing. In the
Yeah.
case of two-seater, it is in the between. So the number of data points which is related to two-seat are evenly distributed. That's what you're saying. In the
Yes.
case of, and when it comes to this second compact one, the median is a little bit off the middle value, right?
Yes.
So what
Yes.
does it mean in that sense? In that case,
Okay. So it means that uh, the distribution or the number of values which are lower and higher is sort of different, and there is a difference between the distribution to the right and to the left of a value, right? So there is the balance is not there. So for example, let me give you one simple example. Maybe I'm not able to tell you using words. So there is a data which has these five values: 2, 2, 3, 10, 10. So what is the median? 3. right? Because two values are smaller and two values are bigger than 3. 2, 2, 3, 10, 10, right? There is another data set which is 2, 2, 3, 4, 4. Again, the median is 3. So how do you compare the two data sets,
So
So the
right?
dispersion is high in the first you are mentioning, than in the second set, where the data points are quite closer to each other, 2, 2, 3, 4, 4, and the other case there are extreme different values. Like the extreme range is 2, 2, median is 3, and the extreme upper range is 10, 10.
Right. Okay, so again, let's not go to statistics because statistics is
Right.
something that would require a different way of teaching and not this way. All right, so let's come back to R, right? Okay, let me try the same thing which I was trying before because I was not able to run it because of that plus. Yeah, I got it now. So if you write this notch equals to true, the boxes would look tapered, in the center. So this tapering means that where is the how does the data uh, the count of the data move as you go far on either side of the median, right? Uh, if you want the color of the outliers to be different than the rest of the colors, so you want them to stand out in color, you can write outlier color, outlier dot color equals to something else, not red, right? If you want to differentiate, maybe you can say black. So the outliers will not be of the same color as the boundary of the boxes. So you can see them clearly, or maybe any other color you can give. You can change the outlier shape also because in box plots these the main one of the main ideas is to show the outliers, right? Of course you want to show the q1, the q3, and the median also, and you want to show the interquartile range also. So a lot of things to show, but one of the things is the outlier. So there are a few things you can do with the outliers. Outliers dot shape. Okay, you can see these many things you can do with the outlier: size, shape, fill, color, alpha, right? So let me show you the size and the shape, right? So outlier size equals to, that would make them a little bit bigger, and outlier shape to be anything. I mean, maybe shape 2. Shape 2 will be some shape, so it's a triangle actually, right? Now there are some shapes which have boundary and the inner part, right? Like this triangle. There are some shapes which don't have a boundary and an inner part. They have only one solid shape. In that case, you can use color. But if there are two parts of it, the outer ring or the outer part and the inner part, then you have to use fill for the color. Not the color for the color, but fill for the color. So
Uh, Here with outlier shape, you mentioned equals 2 and which came as triangle. So how do we know that? Cannot we just write it outlier dot shape equals triangle or square?
no, you have to give the number, or you have to give a letter or an alphabet, or you have to give a dot or some sign, but you cannot write words.
Okay.
Yes, sir. Same my question. Do we have to remember these things, these number two and these things?
Yes, I mean, there are some shapes which you will feel comfortable with, and you will remember those three, four numbers, and you will use them again and again. So,
Okay, sir. Okay.
if you want to see which number represents what shape, you can just change the numbers and see yourself that what are the shapes associated with these numbers. I think there are 26 of them.
So do
Okay.
we, so will you provide some notes regarding how the shapes and whatever, so we get some kind of a ready-made format, so we can just like, so because these terms are completely new for me.
I think we
Uh,
have to practice on our own and keep experimenting.
True, but still, like some at least if you have some material, so at least we can refer the shapes and.
I don't have any material to be honest,
Okay, sir.
and uh, I will. I always go to Google.
Okay, sir.
So
I mean, the best way what Arrow says is like learning by doing. So,
Sir, notch doesn't work for me.
okay.
So I have one more question. So do we so R does R provides like from visualization we get the coding, like we can import the visual and then we can get the coding. Something is there like, I mean I don't know, is it the valid question?
Uh,
So now what the image has come out, you will import this image and you get a reverse calculation kind of. Is it, can R provide that?
Reverse calculation. So you save the code and you can do it again
No,
because
no,
it's with
no. So
you.
I just have this image with me and I want to see how
No,
the,
no, it can't be done. No,
no, nothing. Okay, sir.
no way.
Okay, got it.
There's only one way to go ahead. Start from here and move ahead.
Okay, sir.
In R, you can't get the code from the image. Maybe if you go online, I don't know these days, and maybe if you there is something where you put the R image and then it will give you the code that was used to make it.
Mhm.
Might be possible, but I have never done it. I don't think it is done.
Okay, sir.
Can the help us in terms of these
Yes,
codes?
yes, yes. If you place a question mark and write geom underscore box plot and run it, it will show you everything about the box plot. Arguments. What does this mean? What you can write where. So when uh, I have this habit of forgetting things, so I will forget what I've done, and then I'll go to this help menu to just see if I can revise it and get it back. And of course, Google is there. So
Yeah, yeah, because these are very specific, right? So
yes, yes.
it would one has to keep. Okay, so question mark followed by the geom box plot.
Geom box plot, geom line, geom this, geom that, anything.
Okay.
Even ggplot. So ggplot, and it will tell you about ggplot. What is ggplot and what does it contain? How it is written, right? So a lot of documentation. So that is also one of the biggest one. I mean, great thing with R that it has a lot of documentation on everything, and it's there in the software itself. And then uh, a bigger advantage is that a lot of people, the community which is using R, is there. It's a big community, so there is no problem which doesn't have a solution in R. If you Google it, you'll find it readily, right?
So did we run this line 32? Did we run it?
Yeah, we did run it. 31 line number 31, 32 up to 38, up to 39. Let me run it again. It's running. Here's the plot.
Sir, could you explain notch again? I couldn't understand this.
Notch is just changing the box plot from a flat flat one to the notched one, where there is a notch above and below the median, or if you're doing it horizontally, left and the right of the median, and it will taper out median onwards on both sides, and that will show how the distribution is. So how fast it is coming out, or does it come slowly, right? So that would tell us what is the density of the points there. If the density is close to the median, this will taper out rather quickly. If the density of points near the median is very less, so there are very few points near the median, right? And there are points which are more points which are far from the median, then this will taper out rather slowly.
Okay, sir.
Yeah, I think I made my point clear, but again, when you work on it and experience it and read something on it and all those things, you will get a better idea, because suddenly things doesn't come to mind. All right, so let's do one more thing. We have 15 minutes. So let us do a histogram. It is also a very common thing, so that's why I'm choosing it. Uh,
So,
Let me use. Okay.
Just
so I
Yeah,
have
just before
a
you move
question.
on,
yeah, please.
yeah. So I wanted to just again ask this in this ggplot, MPG is your x-axis, right? And
Yes,
your that xy, first x and then y, right?
yes.
And all the aesthetics you're doing with your y-axis.
Uh,
Is that how we understand?
so MPG is on the. So let me change this. I mean, remove this coordinate flip, because that is. Let me remove this. Now it is horizontal. And let me remove this notch also, because it's taking time to load. Here is the graph, right? So on the x-axis, we have highway, HWY highway mileage. So you can see that the first one is the x-axis,
Okay.
and the second one is class. So second variable is mapped to the y-axis, and that is class.
Okay.
Highway, HWY highway mileage is a continuous quantitative variable. So any box plot is done on a continuous quantitative variable. It can't be done on a categorical variable like class,
Right.
right? Due to statistical reasons, right? Which I don't want to explain now. So uh,
Right.
here
Uh,
the
so
data
the
set is MPG, the data set, name of the data frame in which we have this variable highway mileage, we have another variable class, and we have many more variables which we have not used here. So MPG is the name of the data frame, and then highway mileage is on the x-axis and class is on the y-axis, and then the geometry is box plot, and then whatever is written here are the characteristics of the box plot. I mean, attributes in terms of color and shape and size of the box plot.
okay, thanks. Yeah. I know I got confused. Thanks. Yeah.
Okay. Okay, so let us view this data set. It's about diamonds.
So,
Yeah.
sir, how did x-axis, y-axis interchanged when you remove this notch? And earlier
No.
also, my axis was coming this way also only, not highway in the x-axis and class in the y-axis.
So this is the default graph which you can see now. That's how you will get it. But if suppose you want to switch the axis, if you want to switch the axis, then you have to write a plus and then write COORD underscore flip and then run this. This will flip the axis.
So your earlier graph was chord flip. You already run that chord flip.
Yeah, I did chord flip, and then it was confusing the audience because HWY should be on the x-axis, but it was on the y-axis, and class was on the y-axis and it was on the x-axis, so it was confusing. So I removed it. Right?
So just one clarification before you move ahead with this new dataset diamonds. Was
Yeah.
there any command over there as median something? I have missed out that part.
Median.
Median,
Okay. So
MPG and all.
if you want to calculate the median of the
Uh,
data,
uh,
you can simply write median, and you have to give the name of the variable. But before the giving the name of the variable, you have to give the name of the data frame. So
so, okay.
suppose I give HWY, and then we use a dollar sign to go into a data set. So when I'm writing, sorry, not HWI, what is the name of the data set? MPG.
MPG.
MPG. And then when you put the dollar sign, it will show you what is there inside it. Then you can select any variable for which you want to calculate the median. So I selected
Oh,
HWY, and then I ran this line. It gave me the median of 24.
acha. Okay. I missed out that part. And sir, notch, can you just briefly explain? I didn't get that part also. Give me a second explanation.
Uh, okay, notch. I explained 2 times.
That's why I said I didn't understand the second time also.
Okay. So when you write notch equals to true, it will alter the shape of the box. So box will become notchy. It will there will be it will taper out from the median, right? And the speed with which it tapers out would depend on the concentration or the density of the data points moving either side of the median, right? So it's a very minute thing to observe. There is not much need to see that. I mean, Boxplot already has a lot of information. So if you want to understand the notch better, you can read the documentation, go online, search it, understand it, the statistics behind densities and distributions and all those things. So
Okay, sir.
yeah, right. All right. So I was using the new data set, view diamonds, and then when you let me explain a little bit about what this data set is all about. So there are 53,940 rows in this data. It's a huge data set. There are 10 variables or 10 columns, and each column is a vector, and each column is a variable, however you call it. Uh, or each column is a characteristic of diamonds. So there are 10 characteristics of diamonds, uh, one column for each characteristic, and each row is one diamond. So this diamond number 4 has a carat of 24. So you can think of it as the weight of the diamond. Then it has a cut of premium. So this cut can be quality. Is it premium? Is it good? Is it ideal? Is it very good? Is it fair? So there are some 5, 7 qualities of diamonds. So that is the variable cut. And then the color of the diamond, A, B, C, D, E, maybe 10, 12 colors are there. Clarity of the diamond. Again, there are 5, 7 categories of clarity, maybe more than that. I didn't see that. Then depth is some measurement, vertically, horizontally, depth table, and then price. This price of diamond is, I don't know, is it in dollars or is it in thousands of dollars? It is the price. And then X, Y, Z are also some measurements of each diamond. So this is the data set that we have. What you should pay attention to is that carat is our numbers, depth table price X, Y, Z are numbers, while cut, color, and clarity are categorical variables. Right? So there are three categorical variables: cut, color, and clarity. Rest others are measurements on diamonds in centimeters, in maybe millimeters, or price in dollars, or this carat in maybe in grams or milligrams, or you can just put a question mark ahead of diamonds to understand more about the data set. So it will give you prices of over, okay, it is based on the most important variable is prices over cut, right? Price in US dollars, carat weight of the diamond, cut quality of the cut, and all those things. So let me plot this. And I want to do a histogram actually. So what is a histogram? It's sort of a bar plot, but a bar plot is done for categorical variables and a histogram is done for continuous variables. This is the difference. So I'm going to use one continuous variable and I'm going to see its distribution through histogram, right? So let me do it for weight or carat. So I'm looking into heavy and light weighted diamonds and see, do we have more diamonds which are light in this 50,000 diamonds? Do we have more heavy diamonds, or do we have some sort of similar numbers of heavy and light diamonds in the data set? We want to see this distribution using histogram. So I'll use the command ggplot. The first argument is the name of the data set, so it is diamonds, and then the second argument is AES, and histogram can be done for one variable, so that will be the only variable that I will use. And let me use carat, and then the geometry will be histogram, and run it, and that's the histogram. So what is your observation? By looking at this histogram. Of course, I'll explain. Okay, let me explain because the time is less. So what I see here is that there is this one big bar in the beginning. So that is a light carat or lightweight diamond. So there are lots and lots of lightweight diamonds. If you go somewhere in the middle around 1 and 1.5, there are fewer diamonds. If you move to 2 and more than 2, there are very, very few diamonds which have this much of weight. Right? So the distribution is more skewed to the right. We're talking about skewness. Whenever we talk about a histogram, we are talking about skewness. Do we have a skewed data, or do we have a normal data that doesn't have a skewness? This data is very skewed, and it is skewed to the right. So skewness is positive, right? Skewed to the right means positive skewness. So if you calculate the skewness using a formula, using this data, you'll see that it will have a positive skewness. Okay, let me improve this histogram. It's looking very blunt and bad. What can we do with this to make it more informative, to make it more visually appealing? Okay, before that, one thing which I missed is, what is there on the y-axis? Count. So
The
count
number of
the count of diamonds. So there are 15,000 diamonds which have a carat of somewhere between 0.2 and 0.3, right? And if you see this area is from 0.2 to 0.6, and there are lots and lots of diamonds there. And when you go from 1.5 onward, there are very few diamonds, maybe somewhere around 1,000 or 500 diamonds here. Right? So So the count is there on the y-axis, how many of them are there. So that makes this data skewed because there are less diamonds towards the higher side of the data, and there are more diamonds close to the lower side of the data. Okay, so let me start with on the same lines. So what is the color? So color should be black. And what is the fill? Fill, let me make it pink. And let me see how it looks. So that's how it looks. Uh, Another important thing that can be done is bin width. So bin width equals. So how many bins do you want? If you see here, how many bars are there? Maybe 10, 12 bars are there. So if I reduce the bin, if I increase the bin weight, uh, maybe let me make it 0.5. Then I'll see what happens to it. Okay, even fewer bars, 0.5 is not a good idea. So 0.2, better. Let me make it a very, very small bin width, maybe 0.05. So now we see the distribution more accurately. We can minutely see where the data is, how the distribution of the data is when we reduce the bin width. So when I have reduced the bin width to 0.05, I can see more bars. And when I see more bars, I'm increasing the accuracy with which I can see the distribution, right? Or instead of using the bin width, I could have used number of bins, right? So let me remove this and let me write bins equals 100. So 100 bins are there. If I make it 25, you'll see broader bars. So not a good idea. 100. 100 is good. Right. So that's about bins or bin width. One of them should be used. Both are doing the same thing. You increase the number of bins or you reduce the bin width. Both will have the same effect on the histogram. And the reason why we change the number of bins or the bin width is to see precisely into the data. Now there is a downside of it. If you don't have many observations, increasing the number of bins will not have that effect of precision with which you can see into the data. You will not be able to do that. You will not be able to see that precision because already you have very few data points, maybe 100 observations or 50 observations. This increasing the number of bins will not help you. So it all depends on the size of the data set. If it's a big data set, then you have this freedom of changing the bin width or number of bins, and that will enable you to see more deeply and precisely and accurately into the distribution. For example, I can see another big bar coming around 1. So now I can conclude that this there are lots and lots of diamonds around a carat of 1, which I was not able to see before because this was subsumed in a. If you see just beside this bigger bar, there's a smaller bar also, and when you mix these two, this wider bar will be half of this size. So that information will be subsumed if I increase the number of decrease the number of bins. Right? I hope I made it clear. Again, I am going into statistics, so let me not go much into that. What about if I take one more variable here? Maybe, let me see, color. Okay, so it is not plotting. I was hoping to get, uh, one histogram for each color. So I was not able to achieve it. So I have another way. So let me use, what was that? Not coming to my mind. Okay, I'll let you know all of these things which I am forgetting tomorrow, definitely. In the meantime, if you have any question, you can ask.
Sir, if you remove, I think if we remove plus, then we can get a blank plot. Like if I just remove plus after double brackets. So तब तो I was getting a blank plot of like carrot and color.
If I remove the plus,
Hmm.
of course, I mean, plus
Huh.
means that I'm adding a layer to it, to the blank
Yeah.
canvas. So if you're not adding any layer to the blank canvas, nothing will be there. Okay, I got that. Facet underscore wrap. And let me include this. Let me remove this from here. I can put it in the facet. Of course, I'll have to explain you what is facet wrap. But for now, I'll not explain. I'll just show you. And what I was using, color. Am I using the correct spelling? Yes. Let me use cut. Color equals black. Ggplot diamonds. Okay, I removed that AES part also while I deleted everything. So at least I have to put the x-axis thing. So what was there on the x-axis? Cut. No, it was carrot, right? Carrot. It should work now. Here it is. So I got as many histograms as there are categories of the variable cut. So there are 5 categories. So I got 5 histograms here. The ideal cut diamonds are shown in this last histogram, and the fair quality or fair cut diamonds are shown in the first histogram. So separate histogram for each cut, each category of the cut. Right. I was thinking I will be able to achieve it from here, but it could not be done. But this is another way. I'll explain this tomorrow. I'll be happy to answer your questions for 2 to 3 minutes now. If you have anything to ask, any suggestion, or anything that comes to your mind. All right. So if there are no questions, should I end the class? Okay. So thank you so much, and see you tomorrow. I'll be uploading the video, this recording, and also the code on the WhatsApp group, and the recording will go on the same link. And that I will do tomorrow morning. So, but code I'll send you right now. So thank you so much. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.